Somya Singhvi. I'm an assistant professor in the Data Science and Operations group at USC's Marshall School of Business. I completed my PhD from MIT's Operations Research Center, and before that I did my undergrad from Cornell University in Operations Research and Information Engineering. My research has focused on a particular branch of operations management, which is sustainable operations. This branch focuses on using operations management tools to ultimately improve welfare and supply chains, improve welfare and societal outcomes in digital platforms and so on. In terms of my research methodology, I have used a combination of field-based and data-driven tools to ultimately improve design of digital platforms and supply chains. In terms of application areas, this has meant that I worked with collaborators in a diverse set of domains, including agricultural supply chains, artisanal supply chains, healthcare supply chains, educational tech platforms, as well as charity donation platforms. Through most of these research projects, the focus is to use operations tools, optimization tools, to ultimately drive impact in practice. Our project focuses on a particular type of artisanal supply chain, which is handmade rugs. These handmade rugs are produced by individual artisans. Most often these artisans are women in rural areas, and as you can imagine, because of social constraints and boundaries, these women have to work from their individual households. So the production happens at an individual household level, often in very geographically isolated regions. In terms of the actual setup, the process, often what happens is raw wool is first hanged, and this raw wool is sent and threads are then dyed and threads of different colors are produced. A design map is then generated, and weavers are then expected to follow this design map when they are producing a particular rug. Now this is a very labor intensive task, and on average in our data set what we find is more than 2 months of time taken to complete just one rug, because of the intricate design and patterns that are ultimately being generated. Once these rugs are generated, these rugs are then sent for further finishing before being sold through multiple channels, including online platforms, retail stores, as well as exports. Now one point I want to highlight here is that rug making is a very labor intensive task, and a variety of factors ultimately affect productivity or weaving speeds of the weavers. This includes number of colors in the rug, the type of design in the rug, the density of the rug, or in other words the quality of the knots that are being weaved into the rug, and so on. So a key area that we focus on is supervision, and as I mentioned, many of the weavers that ultimately produce these rugs are in geographically isolated regions, and a key differentiating factor for such supply chains is the very nature of production. So in contrast to factory setups, where you can have supervision throughout and at very frequent intervals, because of geographical isolation, you cannot expect that kind of setup in such supply chains. So a key factor is supervision. This comes out because supervisors have to make significant effort to visit a weaver at any given point of time. For factory workers, this would not happen. This would never arise because you would observe them on standard factory floor operations. So one key aspect is supervision. The other I would claim is also the type of designs that we have artisans working on. If we are able to use AI machine learning based tools in identifying designs that are most remunerative as well as easy to weave, then we could again see significant increase in productivity. Indeed, so that's a very fair point. Geographical isolation is not a challenge that is limited to artisanal supply chains. Similarly, low productivity is not a challenge that is just limited to artisanal supply chains. These issues arise in many other supply chains. One example that comes to my mind is agricultural supply chains. Again, what you have is smallholder farmers who are spread across a vast geographical area, and many of them suffer from very low productivity. Figures suggest that productivity for farmers in developing countries is actually only half of that of many developed countries. So really, geographical isolation and low productivity are common aspects that are shared by many other supply chains where production happens in an isolated manner. And in terms of the tools that we develop, I think the tools that are identified through this research can actually be applied to tackle these challenges as well. At the end of the day, if you think about agricultural supply chains, extension workers that are employed by government in large numbers are ultimately aimed at identifying what are the right sets of seeds, fertilizers, and other tools that can be used by farmers, and how to effectively make sure that this information is available to farmers in isolated regions. And ultimately, if you want to make this process effective, if you want to make sure that this information gets transferred to smallholder farmers in isolated regions, well, you have to think about operations of extension workers, how to make sure that their routes, their logistics are optimized, that they are able to reach the right set of smallholder farmers. So both the challenges as well as the solutions identified through the research ultimately can prove to be very significant help in these other supply chains as well. Very good question. So in terms of strategies, the first strategy that I'll talk about is what we focus on in our research, which is supervision. A key question is how often do you supervise these workers who are working in geographically isolated regions? As I mentioned, in factory floor settings, you can easily increase supervision because there is not much effort that's needed. But in supply chains which are distributed in nature, this is not very easy to do. You can't ask a supervisor to visit 100 weavers or 100 farmers who are spread across, let's say, 200 kilometers in a day. So really you have to be careful in resource constrained settings about where to put your resources. And this is what we focus on. What we show from our research is that supervision can have a very significant and positive role on productivity. And importantly, this effect is heterogeneous in nature. Weavers who are working on more difficult rugs are more likely to benefit the most from increased supervision. And based on that, what we develop is a predict then optimize approach, where we use machine learning based tools to first identify which weavers are likely to have lower productivity. Based on those ML based predictions, we then solve an optimization based model to optimize supervisor routes, which can ultimately target these low productivity weavers in a more effective manner. So this is one intervention that is focused more on supervision. You can equivalently think of other areas in which productivity can be improved. One area is the matching itself. Often what happens currently is assignment of particular rugs to particular weavers is done in an ad hoc manner. But if you think about it, there are particular skill sets that weavers gain, and these skill sets can be affected by a variety of factors. Similarly, there are particular skill sets that are needed for rugs to be completed. Now, if you think about it, this assignment or matching problem is an optimization problem, and we can write an optimization problem taking into account these factors and figure out what is the right matching between different rugs and different weavers, and ultimately solve this problem in a dynamic fashion. The last intervention that I'll talk about is incentive schemes. Currently, the reward structure for most of the weavers are very static in nature, and they get paid based on a fixed price and the amount of work that is done by them. Now, this reward structure can itself be updated to make sure that weavers have the right incentive to ultimately get rewarded for increasing their effort in weaving many of these more difficult, more intricate patterns, and taking into account through a data-driven manner, we can develop more advanced contracts to benefit the weavers more and improve their productivity. Yeah, so first and probably the most important advice that I can give is to go on the field. What I've experienced from my research projects, both in agricultural supply chains and artisanal supply chains, is data can never tell you the whole story. In order to get that story, that complete picture, you really have to go on the field, talk with stakeholders, identify what works, what doesn't work, based on insights from these interviews, from these visits. If you can combine this, with the data sets that you might have, that can give you insights that potentially cannot be generated just by sitting in your office and trying to make sense from the data. The second key advice that I will give is making sure that the interventions that you identify are implementable in practice. Often when we are trying to identify solutions, as researchers, we get more tempted to focus on problems that are theoretically novel. But if we want to drive impact in practice, and especially social impact in practice, then we have to also think about resource constraints that ultimately affect any setting that we may look at, and how these may play a role when we are suggesting solutions to our partners. So thinking about these resource constraints to start with when you're thinking about solutions is the second key point that I would like to suggest.